Bismillahirrahmanirrahim. Welcome to subsection 3.1.3 process control block. So in this video, we also cover the next subsection 3.1.4 threads. Okay, now we start with PCB first. Okay, so each process will have their own representation, which will represent process using process control block. Okay, so the purpose of PCB, because we want to store an information that is associated with each process. Okay, so among the information that will be represent in PCB, first we have a process state. So process state is referred to the previous section that we have discussed. Okay, well, process number is a unique ID that is associated with the process. It will distinguish the process from all other processes. Okay, then we have a program counter. So program counter is the location of instruction to next execute. Okay, then we also have a CPU register that contain all process-centric register. So both of program counter and CPU register, um, uh, the current value of each program counter and CPU will be saved, okay, in the appropriate fields of the corresponding PCB when a process is interrupted. Okay, um, because we want to allow the process to be continued correctly afterward when it is rescheduled to run again. Okay, next information we have CPU scheduling informations. Okay, such as the process priority, okay, the scheduling queue pointers, so on and so forth. Okay, so for CPU scheduling, we will discuss in detail in chapter 5. Next, we also have a memory management informations. Okay, for example, we store memory that allocated to the process. Okay, for memory, we will explore in detail in chapter 9. Okay, next we have input-output status informations. Okay, for example, we will store input-output devices that allocated to the process. Okay, list of open file. Okay, and also accounting informations such as CPU, the amount of CPU and real-time use. Okay, time limits, clock time elapsed since start. Okay. Okay, so briefly, the PCB simply serve as the repository for all the data needed, okay, to start or restart a process when the interrupt happen. Yeah. So we can say that PCB is kind of data structure that represent a process in operating system. Yeah. So now we look to the next subsection. Okay, threads. Okay, so far, the process that we have discussed, okay, has a single thread of execution only. So meaning that it can perform only one task at a time. Why? Because we only have one program counter. Okay, does program execute one at a time until its completion. Okay, in modern operating system, okay, now we have let's say we have multiple program counter per process. So meaning that if we have multiple program counter, we can have multiple location that can execute in parallel at once. Okay. So for example, at the same time, we allow a process to, let's say, a word processor, okay, where we can type a document. At the same time, a spell checker will do the checking. Okay. Okay. If we allow the operating system or the process to have multiple threads, okay, then we must have a storage for thread details. Okay. Where the PCB is need to expand to include information for each thread. Okay. And also the multiple where we will also store multiple program counter in PCB. Okay, so for track, don't worry, because for track we will explore in detail in chapter 4. Okay, right, that's all for PCB and track. Thank you for watching.